Hey everyone, welcome back to another session of our CISSP study group. I'm B-Dubs and I'm pumped to dive into these topics with you. Whether you're grinding to pass the CISSP exam or you just love geeking out over cybersecurity, you're in the perfect spot. It's awesome to see you all here and I'm thrilled to be on this journey with you. Last time, we dove straight into Domain 5, specifically Objectives 5.1 and 5.2. If you missed it, no sweat. I've got a playlist ready for you to catch up. I'll drop the link in chat so you can watch it later at your own pace. Today we're continuing our exploration of Domain 5, Identity and Access Management, or IAM. So what's on the agenda today? We're picking up right where we left off in Domain 5, which is all about making sure the right people get the right access to the right stuff at the right time, and keeping the wrong people out. We're tackling Objectives 5.3, Federated Identity with a Third-Party Service, and 5.4, Implement and Manage Authorization Mechanisms. So why does this matter? IAM is the backbone of cybersecurity. Without it, your data is basically an open buffet for hackers. Now let's get rolling with 5.3. So what is Federated Identity Management? Imagine you've got a passport that works across multiple countries. There's no need to get a new ID every time you cross a border. That's FIM in a nutshell. It's all about sharing identity information across trusted systems, often with a third party, so users can move seamlessly between apps or organizations with single sign-on. Now let's think about some examples you might encounter in the real world. First, think about your average enterprise employee. They come into work, open their laptop, and with just one login, they can access both Salesforce for customer management and Microsoft 365 for their email and documents. That's federated identity at work. One set of credentials unlocking multiple systems. Another great example is university students. Let's say you're doing research and need access to resources from a partner university's library. Instead of creating a new account, you simply use your home university credentials. The systems talk to each other behind the scenes, verifying your identity and granting access. And in healthcare, medical professionals can use their hospital credentials to access various medical systems. This means a doctor can quickly access patient records, lab results, and specialist reports across different platforms without juggling multiple passwords, all while maintaining security and HIPAA compliance. Now, FIM relies on important protocols like SAML, OAuth, and OpenID Connect, which we covered in our last session. These standards ensure secure identity sharing between systems. But here's the key. It's not just about convenience. There's serious security stuff happening behind the scenes. You need to remember that there's 3 key components that make FIM work. First, there must be solid trust relationships between your identity providers and service providers. Next, we have security tokens. These aren't just random bits of data. They need careful validation at every step. One compromised token could mean unauthorized access across multiple systems. And finally, we can't forget about privacy. When you're sharing identity information between organizations, you need strong privacy controls. Every piece of data shared needs to be necessary and protected. Remember, you're not just protecting usernames. You're protecting sensitive personal information that could be valuable to attackers. Compare this to traditional identity management, where you'd need separate accounts everywhere. FIM eliminates that hassle for the end user and administrative overhead while maintaining security. But hold up, it's not all smooth sailing. We'll get into the risk in a bit. Now, federated identity management can be deployed in 3 main ways, each with unique characteristics that fit different organizational needs. First, we have on-premise deployment. This means running everything in-house, like setting up your own Active Directory federation services right in your own data center. Think of a large bank that needs complete control over its authentication systems for trading platforms. They'd likely choose this approach. On-prem identity management offers several key advantages. When you control your own infrastructure, you have complete control over your security setup and data management. This is especially important if you're in a highly regulated industry like healthcare or finance. You can customize every aspect of your authentication processes to to match your exact needs. Plus, you maintain direct oversight of all your security measures, which means better compliance and faster response times to security issues. But here's the reality check. There's significant trade-offs to consider. You'll need a dedicated IT team to keep everything running smoothly. This isn't just about hiring a few technicians. You need experts who understand identity management inside and out. When your organization grows, scaling up your infrastructure becomes complicated and expensive. Think new servers, additional licenses, and enhanced security measures. Then there's the maintenance costs. Between hardware upgrades, software licenses, and that specialized IT team, the expenses can quickly add up over time. Next is cloud deployment, where you outsource your identity management to providers like Okta or Azure AD. Imagine a modern tech startup. They might use Okta to manage their employee logins across various applications. It's essentially like having a digital secretary that handles all your access credentials and permissions. So what makes this approach so powerful? The scalability is incredible. Your system grows seamlessly with your company without requiring new servers or additional IT staff. Maintenance is effortless since the provider automatically handles updates and improvements. Plus, you can launch quickly with minimal setup complexity. However, there's some important trade-offs to consider. Your authentication system depends entirely on your provider's uptime. When they're down, you're down too. You also have less direct control over your security infrastructure, since you're trusting the provider to handle it. Additionally, data residency presents a challenge for many companies, with strict laws in some countries about where sensitive data can be stored. Having identity data in the cloud can create compliance complications. And finally, we have hybrid deployment, a blend of on-premise and cloud solutions that offer the best of both worlds. Picture a healthcare organization. They maintain sensitive patient records on their secure local servers, while leveraging cloud services for everyday tools, like email and team collaboration. A hybrid deployment model offers significant advantages by combining the best aspects of both approaches. The robust security and control of on-premise systems, along with the agility and scalability of cloud services. So what makes this hybrid strategy so powerful? The biggest advantage of using a hybrid deployment is that it gives you incredible flexibility while maintaining strong security controls. So what do I mean by that? First, you maintain complete control over your most sensitive data by storing it securely on your own servers. This is important for organizations handling highly confidential information or facing strict compliance requirements. You can implement your own security measures, maintain direct oversight, and ensure sensitive data never leaves your premises. At the same time, you can leverage all the benefits of cloud services for less sensitive operations. This means gaining the scalability, cost savings, and convenience of cloud computing where it's appropriate, while keeping your crown jewels safely under lock and key. It truly offers the best of both worlds. Now, there's still some challenges you might encounter when implementing a hybrid deployment model. The primary challenge is managing complexity. Your IT team must coordinate and maintain both cloud and on-prem environments, requiring specialized expertise and careful planning. Two critical challenges stand out here. First is system coordination. You'll need seamless integration between your cloud and on-premise environments. This requires careful planning and ongoing maintenance. Second is data classification. You must establish crystal clear policies about what data belongs where, and ensure every team member understands and follows these guidelines. Remember to carefully consider business requirements, including security needs, budget constraints, and available resources. All of these influence your choice of deployment model. The exam often presents scenarios where you'll need to recommend the most appropriate model based on specific organizational needs. Now, Identity as a Service, or IDaaS, is a key player in this space. Think of it as renting an identity management system from the cloud, rather than building your own from scratch. Identity as a Service delivers essential services, all hosted off-site, including user provisioning, account administration, single sign-on, MFA, and directory services. So let's explore these 4 types of identity management. First, cloud identity is ideal for cloud-native companies. Consider a startup that runs entirely on Microsoft 365 and Azure. Their identities exist purely in the cloud. Then we have synced identity, which is perfect for companies moving to cloud services. Think of a bank that keeps its core user directory on-premise, but syncs it to cloud services for email and collaboration. Linked identity is suited for organizations using multiple cloud services. For example, when employees use their Google Workspace account to access various third-party tools. And finally, federated identity is essential for large enterprises with complex systems. Picture a multinational corporation where employees need seamless access to both internal systems and partner organizations' resources. Now, when we're implementing these solutions, there's specific security considerations we need to keep in mind. For cloud identity, robust cloud security controls are essential. This includes firewalls, encryption, and access management. Plus, you'll need redundant internet connections, because if your internet connection goes down, so does your authentication system. With synced identity, security gets a bit trickier. You need to establish secure channels for synchronization through encrypted tunnels between your on-prem systems and the cloud. Plus, you've got to carefully manage duplicate data to prevent inconsistencies. For linked identity, federation protocols take center stage. This requires robust SAML or OAuth implementations. And don't forget about continuous monitoring of those linked accounts, as a single compromised link can compromise multiple systems. Finally, federated identity hinges on trust. Strong trust relationships between all parties are essential, and secure token management is absolutely critical. These tokens are like digital keys to your kingdom, and they need to be protected at all costs. Cloud identity works best for cloud-native organizations, while synced identity helps traditional businesses move to the cloud. Linked identity provides flexibility when users need both local and cloud access. And federated identity simplifies access management across multiple applications. All of these identity-as-a-service options make managing identities simpler. Now let's examine the key risks of identity-as-a-service because there's some really big ones here. First is availability. If your cloud provider experiences an outage, you could be locked out and lose access to all of your systems. Imagine facing a CISSP outage during a critical project deadline. That's a problem. To mitigate this, implement a strong disaster recovery plan that includes a secondary identity provider or on-prem fallback system, and regularly test your failover procedures. Second is the protection of critical identity data. Your PII and sensitive information are stored in the cloud, and weak cloud provider security puts this data at risk. Look for strong encryption for both data at rest and data in transit, and verify provider credentials like SOC 2 compliance. This is especially important for global organizations that must navigate different data protection regulations across various countries. Third is the risk of entrusting sensitive data to third parties. Beyond PII, providers can gain insights into your organizational structure and hierarchy. A security breach or untrustworthy provider could expose these secrets. You can mitigate this by thoroughly vetting potential providers, reviewing and analyzing their data policies, and establishing contracts with strong confidentiality provisions. Fourth, and this is a sneaky one, is vendor lock-in. Deep integration with an identity-as-a-service provider makes switching providers as challenging as trying to change engines mid-flight. You might find yourself trapped with a provider despite service degradation or price increases. The solution here is to maintain a flexible architecture that allows for provider changes when needed. Now remember, for the exam, focus on risk mitigation strategies, redundancy, encryption, compliance verification, vendor assessment, and architectural flexibility are all your best friends here. Now that we've covered federated identity and authentication, let's shift gears to Objective 5.4, implement and manage authorization mechanisms. While authentication proves who you are, authorization determines what you're allowed to do. Think of it like this. Having a key to enter the building is authentication, but knowing which rooms you can unlock is authorization. For example, when you're at work, you might have access to your team's shared drive because you're authenticated as a team member, but you can't access the HR database or financial records. That's authorization at work. This concept is so important in access control. It ensures users can only access what they need to do their jobs. Next, we'll take a look at different approaches through various access control models, such as DAC, where users control access, MAC, where the system controls access, RBAC, which is based on controls, and ABAC, which is based on attributes. Each model offers a unique way to answer the fundamental question: what are you allowed to do? Now let's explore access control models. We'll cover several key approaches, including DAC, MAC, RBAC, and ABAC, along with context-based, risk-based, and non-discretionary access control. Think of these as different security personalities. Some are flexible, while others are strict. We'll also examine XACML, which helps implement ABAC policies effectively. Each of these models have distinct strengths that make it ideal for specific organizational needs. We can look at a few scenarios to understand which access control model works best in different situations. For the first scenario, a bank needs to implement customer data access controls with strict oversight and detailed audit trails. This is perfect for RBAC combined with ABAC, where roles establish baseline access permissions, while attributes like time, location, and transaction amounts provide additional security layers. For the second scenario, a startup needs a flexible and collaborative workspace where permission changes happen quickly. DAC is ideal here, so team leads can manage access to their projects directly, allowing teams and projects to evolve rapidly. And for the final scenario, a government research facility handles classified information. This calls for MAC, where the system enforces strict, hierarchical security classifications that users and owners cannot override. We'll look at each model in detail to understand why certain scenarios align with specific models. Now let's start with discretionary access control, or DAC. In this model, the asset owner has complete control over who gets access. As the name suggests, it's at their discretion. This ownership-based model is considered a security best practice, since owners are ultimately accountable and know best who should access their resources. You encounter DAC in everyday scenarios. When you right-click to set folder permissions in Windows, that's DAC in action. When you adjust your social media privacy settings to control who sees your profile or posts, that's DAC too. Even when team leads manage project access in collaboration tools, yep, that's DAC. Let's examine the technical mechanisms that make DAC work. The most common one you'll see is access control lists, or ACLs. These are essentially lists that specify which users get which permissions. Capability lists flip this around, showing all actions a specific user can perform. Access tokens are like digital keys that prove a user has the right to access something. Permission matrices provide a clear visual grid mapping users to their allowed operations. DAC's strength lies in its flexibility and owner-driven control, which is perfect for collaborative environments. However, it still comes with risks. Careless permission management or poorly handled ownership transfers can lead to security vulnerabilities through permission sprawl or orphaned access rights. For effective DAC implementation, you should follow these critical practices. First, conduct quarterly permission audits, or more frequently in high-security environments. This means reviewing who has access to what resources and whether those access rights are still appropriate. Next, maintain up-to-date ownership documentation. Clearly identify who owns and manages each resource. Then, implement strong offboarding procedures to systematically review and revoke access when people leave or change roles. And finally, always use default deny policies. Users should not have access to resources unless explicitly granted. It's much safer to start with no access and grant it as needed, rather than the other way around. A quick note here about model overlap. While role-based access control and attribute-based access control can be discretionary if owners define the roles or attributes, For CISSP purposes, we still treat these as distinct models. Remember that DAC distinguishes itself by empowering owners, unlike system-controlled models like MAC. In scenario questions on the exam, DAC typically fits best when flexibility and owner control are priorities, especially in collaborative business environments. Now, I want you to imagine Mandatory Access Control, or MAC, as a classified document facility where a central security office, not individual employees, controls all access. With MAC, the system enforces all access decisions, not the asset owner. MAC relies on security labels, such as unclassified, confidential, secret, and top secret, to control access. Every asset receives a classification level, and every user gets a clearance level. Access is only granted when these levels match. If they don't match, then no access is granted. For example, an employee with confidential clearance cannot access secret documents. While MAC excels in high-security environments like military facilities and intelligence agencies, it's really rare to see it in your typical businesses. Why? Because MAC requires labeling everything and managing clearance levels. Every document needs classification, and every employee needs a security clearance. This administrative burden makes it impractical for most business environments. Remember that MAC works best in government intelligence agencies, nuclear facilities, and classified research labs. However, it would be impractical for organizations like marketing agencies or retail businesses, where collaboration and flexibility are key. Next up is Role-Based Access Control, or RBAC. This ties access to specific roles, creating a structured way to manage permissions. If you're a manager, you get manager-level permissions. It's simple, right? RBAC often uses role hierarchies, where higher-level roles inherit permissions from lower ones. For example, a senior manager automatically gets all manager permissions, plus additional privileges specific to their senior role. Now, there's two main types of roles in RBAC systems. Static roles are like permanent job titles. They have a fixed set of permissions that stay consistent. Think of a standard HR staff role that always needs access to employee records and benefit systems. Dynamic roles, however, can change based on conditions or time periods. For example, a temporary project lead might get extra permissions while managing a specific project, and then return to their normal access level when the project ends. The big advantage here is that RBAC makes administration easier. You manage roles instead of individual users, and changes to a role automatically apply to everyone with that role. The downside, though, is that in large organizations, you might end up with too many roles, which can get really messy. Role inheritance can also make it tricky to track exactly who has what permissions. While RBAC can technically be discretionary if owners define the roles, it's typically listed as its own model for clarity. Remember that RBAC is a CISSP favorite. Know its strengths, weaknesses, and hierarchical structure inside and out. Now, Attribute-Based Access Control, or ABAC, is the flexible champion of access control systems. ABAC makes decisions based on a wide range of attributes, including job title and role, device type and security status, time and location, asset sensitivity, security clearance level, resource classification, current risk level, and IP address. It's perfect for dynamic environments like cloud applications where simple role-based rules just aren't enough. For example, if your policy states that managers using company laptops can access budget sheets, but only during work hours and from corporate networks, that's super granular. Unlike RBAC, which only looks at roles, ABAC evaluates multiple attributes to make more sophisticated decisions. There's a tool called XACML, which stands for Extensible Access Control Markup Language. This is an XML-based standard that helps organizations define and manage ABAC policies consistently across platforms and systems. This standardization makes it easier to implement complex enterprise-wide policies. The benefits of ABAC include incredible adaptability and precision. However, the initial setup can be really complex. Think of ABAC as a detail-oriented bouncer checking not only your ID at the door, but also checking your dress code, VIP status, time of day, location, and security clearance. Everything must align perfectly in order to gain access. Now let's explore context-based access control. This model evaluates environmental factors to make access decisions. Think of it as a smart security system that adapts based on the situation. When you try to access a system, there's quite a bit that's happening behind the scenes. Imagine logging into your company's network remotely. As soon as you hit that login button, the system springs into action and doesn't just check your username and password, it gathers contextual information about your access attempt. Now, when a user attempts to access our system, we analyze several important security factors in real time. The first is location. Where is this access attempt coming from? If someone who typically logs in from the office suddenly connects from another country, that raises some red flags. Next, we evaluate network security. There's a significant difference between connecting through our secure corporate network versus an unsecured public Wi-Fi at a coffee shop. We adjust security measures accordingly. We also consider timing. Is this access attempt happening during typical business hours or at 3 a.m. when most employees are asleep? Finally, we check device health. Is the connecting device properly updated with security patches and meeting our security requirements? We don't want to risk compromising our network by allowing access from vulnerable devices. Now, based on these factors, the system makes access decisions that align with the security policies while considering the current context. Now, let's look at how this works in practice at a financial institution. When employees work from their desk in the office building, they're in what's considered the trusted zone, where they typically have full access to their needed resources. They've already passed physical security and are on the secure network. Remote workers are handled a little differently. During business hours, they can access what they need, but they must connect through the secure VPN first, creating an encrypted tunnel to protect data transmission over the internet. So what happens if we detect an access attempt from overseas? That's an immediate red flag, unless there's a pre-approved business reason, like an employee on a scheduled business trip. These attempts are automatically blocked to prevent unauthorized access from potentially risky locations. Device compliance is important here. If a laptop is missing critical security updates, or if it has outdated antivirus, it must be updated before it can gain access. We simply can't risk having a vulnerable device connect to our network. There's an important distinction to make here. Unlike risk-based access control, which dynamically evaluates multiple risk factors to calculate a risk score, context-based access control uses fixed rules based on environmental factors. It simply checks binary conditions, such as, are they in the office? Yes or no. There's 3 key challenges that exist when implementing context-based access control. First, maintaining accurate context detection. Our security decisions are only as good as our contextual data. Second, balancing security with user convenience. Too many security checks can frustrate users, while not enough checks could leave us vulnerable. Finding that sweet spot is really important. Finally, managing exceptional situations. What happens when a senior executive needs emergency access from an unusual location? Or when our context detection systems fail? We need clear procedures for emergency access or system failures. Remember, context-based access control checks not just your ID, but also where you're coming from, when you're arriving, and what device you're using. Now let me introduce you to risk-based access control. Think of it as a sophisticated security system that continuously analyzes multiple factors to determine if it should let someone in. Unlike simple yes or no rules, it actively monitors various aspects of each access attempt in real time. Here's the key factors it evaluates. First, it examines your behavior patterns. Are you logging in at unusual hours or from an unexpected location? Next, it assesses your device's security status, checking for up-to-date patches and active antivirus. It monitors your location for suspicious patterns, like seemingly impossible travel between New York and Tokyo in an hour. The system also weighs the sensitivity of the data you're accessing and considers your role and security clearance level. When risk levels increase, the system requires additional verification. For example, logging in from a new country at 3 a.m. would trigger multi-factor authentication. Unlike context-based access control with its fixed rules, risk-based access control calculates dynamic risk scores that adapt security requirements in real time. Let's think about a few examples here. In online banking, attempting a large transfer from an unfamiliar device triggers higher security measures, maybe a verification code to your phone, or a call to confirm the transaction. Cloud services constantly evaluate both data sensitivity and user behavior, adjusting security requirements if they detect anomalies like unusually large data downloads. Corporate VPNs analyze both connection source and resource sensitivity. Accessing financial data from a coffee shop Wi-Fi automatically triggers stricter security measures compared to office access. The system offers intelligent security that adapts to changing threats, though it can sometimes frustrate users with frequent authentication challenges if it's not properly configured. Remember this key concept. Risk-based access control systems weigh multiple factors to make dynamic access decisions. Now let's talk about non-discretionary access control, which is essentially the opposite of DAC. In non-discretionary access control, access decisions are made by someone other than the asset owner. Now you might be wondering, when would we actually use this? Let me explain with some examples. First, there could be legacy systems where an ownership has become unclear over time. As people leave the company and departments reorganize, it becomes difficult to determine who owns critical systems. Next, there might be shared resources, like databases that multiple departments depend on. When marketing, sales, and finance are all claiming ownership and all need access, having a central authority make decisions becomes more efficient. Finally, there's always emergency scenarios. During a 3 a.m. system outage, you can't exactly wait for the system owner to wake up and approve access. Sometimes you need to bypass normal ownership processes to maintain business operations. However, giving IT departments this level of control without oversight creates some serious risk. When something goes wrong, and it will, there's no clear trail of responsibility. No one can say for sure who made what changes or approved what access. Access reviews become problematic. Determining appropriate access levels without clear ownership is like solving a puzzle with missing pieces. In regulated industries, this creates significant compliance risks, as many regulations require clear ownership and approval chains. To mitigate these risks when implementing non-discretionary access control, there's a few essential controls you should consider. First, conduct regular asset ownership reviews, where you actively verify and validate ownership assignments. Next, establish clear ownership transfer procedures for organizational changes, such as when departments merge or split, or key personnel leave. Finally, maintain detailed documentation for all non-discretionary access grants, including approvals and justifications. The best practice here is to avoid non-discretionary access control when possible. Instead, ensure asset owners are clearly defined and responsible for permissions. This is a key testing point. Know both the risk and mitigations. Now let's explore how access policies get enforced through two key components: the Policy Enforcement Point, or PEP, and the Policy Decision Point, or PDP. Here's how they work together. The PEP acts as your gatekeeper. It intercepts every access request and says, "Hold up, let me check." It forwards these requests to the PDP, the decision maker, which evaluates them against security policies and then responds with either yes or no. The PEP then enforces that decision, either by opening the door or locking it shut. Let's think about two practical examples you'll encounter every day. First, when you log into your work applications, think about what happens when you type in your username and password. The gateway, that's our PEP, intercepts your login attempt and asks the identity management system, which is our PDP, should I let this person in? The PDP checks your credentials against company policies and sends back its decision. Or think about when you're accessing files on the company network. You click on a confidential document and immediately the file server, acting as the PEP, consults with the access control system, our PDP, asking, Does this person have permission to view this? Based on your level of permissions, the PDP makes its decision, and the file server either shows you the document or displays access denied. Remember, the PEP enforces and the PDP decides. They're everywhere in your security infrastructure, working together to keep resources secure. Now, I want to break down when to use each access control model. Let's take a look at all of these access control models to compare them all. Discretionary access control, or DAC, is ideal for small teams and project collaboration. Picture a marketing team sharing files. They need the flexibility to control their own resources. The key is that resource owners make access decisions directly. Mandatory access control, or MAC, with its strict label-based control, is perfect for military and classified environments, where security levels are non-negotiable. When you're handling top-secret documents, you want this rigid control structure. Role-based access control, or RBAC, shines in medium to large organizations because it scales well. Instead of managing individual permissions, you're working with roles like HR manager or system admin, which dramatically simplifies administration. Attribute-based access control, or ABAC, is our sophisticated option. It's well suited for cloud environments where you need to consider multiple attributes for access decisions. While it's more complex, it does offer incredible flexibility. Context-based access control works great when location matters. Think of a bank that needs different security roles for branch access versus remote access. It's all about where and how you're trying to access resources. Risk-based access control is perfect for environments dealing with sensitive data and remote work. It continuously evaluates multiple risk factors to make dynamic access decisions. Now let's talk about how to choose the right access control model for your organization. This decision depends on several key factors. First, organization size and structure. Small teams might benefit from DAC simplicity and direct user control, while larger enterprises need more scalable solutions like RBAC or ABAC. Second, security requirements. For highly sensitive data or strict compliance needs, consider MAC, or risk-based access control. These provide rigid structure and continuous monitoring. If you need flexibility, ABAC or context-based controls can adapt while maintaining security. Finally, administrative capabilities. With limited IT staff, avoid complex systems like ABAC that require extensive rule management. With a strong security team, you can implement sophisticated approaches like risk-based access control. Now, there's still some common challenges you might face with each model. DAC's biggest challenge is preventing excessive sharing. It's like giving everyone in the building keys. Someone will make copies that they shouldn't. MAC is incredibly complex to administer. Labeling and maintaining classifications for every piece of data quickly becomes a full-time job. RBAC faces role explosion in large organizations, where hundreds or thousands of roles become a management nightmare. ABAC looks great on paper, but managing attribute-based roles is like juggling dozens of variables all at once. Context-based access control requires precise context detection. You must be absolutely sure where and how someone is accessing your systems. Risk-based systems struggle with balance. If it's too strict, then users can't work. And if it's too loose, your security suffers. You have to find that sweet spot. When you're evaluating scenarios for the exam, think about these factors in order: security requirements, organization size, operational environment, and administrative capabilities. For example, a large financial firm, remote workers, sensitive data scenario points towards risk-based or ABAC with strong authentication requirements. Now let's wrap up 5.3 and 5.4 with some key takeaways. For exam objective 5.3, we covered federated identity, extending identity management beyond organizational boundaries, and explored how SSO works with identity as a service to enable single login access across multiple applications. Federation deploys in three main ways. First, on-prem Federation manages employee access to partner portals. Imagine your sales team securely accessing a distributor's ordering system. Next, Cloud Federation connects services like Azure Active Directory to SaaS applications. enabling SSO for tools like Salesforce or Office 365. Finally, hybrid setups balance existing on-prem systems with cloud services, providing unified identity management across both environments. Remember to watch for federation risk beyond availability and trust, things like token hijacking, metadata poisoning, and replay attacks. For exam objective 5.4, we covered authorization models. Let's move from basic to sophisticated approaches. Each of these models serves different organizational needs and security requirements. DAC is the simplest, where asset owners directly control access, like sharing files with specific colleagues. MAC uses strict security labels and clearance levels, perfect for classified environments. RBAC is what most enterprises use today, simplifying management by assigning roles like HR manager or system admin. ABAC considers multiple factors, like your role, location, time of day, device type, before it grants access. And finally, context and risk-based access controls adapt security in real time based on user behavior, location changes, and potential threats. We wrapped up with PEP and PDP enforcement, your security gateway and decision engine working together. Think about how this applies to your environment. Does your organization use Federation for customer portals or RBAC for internal systems? Here's 3 critical exam scenarios for Federation and authorization. First, Federation failure, where hundreds of users are locked out of SSO because it isn't working. What's your response plan for business continuity while addressing the root cause? Next, authorization gaps from implementing the wrong access control model for your environment, leading to excessive permissions. How do you identify these gaps before they become security incidents? And finally, PEP and PDP configuration issues that could create security holes. How do you test and validate these configurations? Now that's it for today's session. You're absolutely killing it on the CISSP journey. Keep that momentum rolling. If you need to revisit anything, no worries. These recordings stay on YouTube and I'll add chapters after the stream so you can jump to specific topics. Mastering this stuff is a huge step towards your CISSP goal, and these concepts will keep popping up. So keep connecting them to real-world scenarios. Stay curious, keep practicing. You're doing awesome. Now who's ready for the after party? I'm heading to our Study GRC Discord servers CISSP voice channel right now. It's the perfect spot for questions, insights, and connecting with the community. If you're not in the Discord yet, you can visit cissp.britwhite.io for the Discord link and grab your CISSP role once you join to get full access to our study channels. Our next session is going to be Tuesday, May 6th at 6 p.m. U.S. Central Time. We'll finish up Domain 5, Identity and Access Management. Thanks for watching, and I'll see you in Discord.